All right, guys. Let's start. So, I hope you can see my screen.
Yes.
Okay. My screen. So what is there is this is what we are going to look at for this week. The next week, there are other stuff we are going part of this networking because I told you guys that networking. I don't know if we dive into this networking. I don't know if we are going to come out in the next 2 weeks, but I know. Let me know what how I'll just organize it. Then I will give you guys the resources to do. And also, although all these ones, as if you know all these stuffs, I don't think there's other thing you'll be looking at in networking. So let's just do the foundational part of the networking. Then other ones, maybe when you get a job, you can learn uh, the job. So, but firstly, we are going to look at what are networks. You know, after that, we look at networking components, devices, and diagram. That's the diagram of networking. Then we look at communication, network communication, how this network communicate. Then after that, we look at the TCP/IP model because I don't want us to uh, get confused. I don't want to bring out all the other model, which is OSI. But I will suggest that you guys will read also that model because I think that OSI is just it uses it's a framework as well for communication. So, but this one it has 7 layers, but this one have 4 layers. So, and I think all the organization is using this TCP/IP model for their communication. So that's why I just let us look at that one. Then maybe we can later we will look at uh, the two model. We compare the two of them, but we are not going to look at the OSI model in detail as we are going to look at this TCP/IP. So, but you can still go and read up that model. Then if you have any confusion there, although this they are the same thing, just that this one uses 7 channels, 7 layers, but this one uses 4 layers. But they mean the same thing. Each layer they mean the same thing, but the 3 layers that make up the 7 layers from this stuff, we just say 1 layer on this TCP. So it's the same thing. So I don't want us to just waste time on that. You can just go through it. If you have any question. So then after that, we look at components of network layer communication. Then we look at format of an IPv packet because as a network analyst or network engineer, if you don't know about this format, when you capture a packet in using a packet analyzer or network analyzer like Wireshark, TCP dump, all these analyzers. If you don't know all these formats, how this packet is being formed and all this encapsulation and other stuff, if you don't know the format, consider that you not understand anything when you capture the package. So you look at the format at which happened. Then after that, we look at operations at the network layer, and finally we look at difference between IPv4 and IPv6. So these are what we are going to look out for in this week, throughout this week. So let's just start. So let's just start. So we are starting with what is network. So we've been hearing of network. I'm networking with this guy, I'm networking with this person, I'm networking with this. So let's look at networking. So a network is a collection of interconnected devices or nodes that are linked together to facilitate communication, data sharing, and resource access. Please hold on. Okay, guys. Like I said, a network is a collection of interconnected devices or nodes that are linked together to facilitate communication, data sharing, and resource access. So you see, uh, let's use a layman understanding to describe this. When your group of friends, you see, you have a group of friends, you see, your group of friends, you guys share information. So that's the same thing that happened in networking. So we networking, we have various type of networking. We have LAN, we have MAN, we have WAN. So that's the same thing that happens in networking as well. So when you two computers are connected together in order to share file, you say that those two systems they are in network. So that's the same thing. So these devices can include computers, servers, routers, switches, printers, and other hardware components. The network allows these devices to exchange information, collaborate with each other, enabling users to access resources, communicate with others, and share data. So at its core, a network consists of two essential components, nodes and links. So let's look at this essential component because this node, let's say node, let me use a router to describe node. Then links is all this cable that's link those computers together. Then after linking them together, the one cable will link those computers to a switch or router. So that from that router, the router will send information to the internet and get the information back. So that's the two essential components in network: nodes and links. Nodes are the devices or entities within the network, while links represent the connections or communication pathways between the nodes. So you see the cable that I see. The links can be physical cables such as Ethernet cables or fiber optic cables, or they can be wireless connections using technologies like Wi-Fi or Bluetooth. So you see these are the links. So anything that links you to the node, that's the router or the switch, anything that links you or your system to that node is what we call the link. That's the two essential components of networking. When we're talking about the computer networking. So let's look at types of networking. Yeah, like I said, we have many of them, but let's just take three. We have uh, local area network. Let's look at the LANs. So LANs are network that's covered a small geographical area, such as a home, office, or school. They connect devices within a limited area, allowing users to share resources such as files, printers, and internet access. So LAN is as you can see in this diagram. So this is a diagram representing a LAN network. So you see the computers are connected together. So all of them they are sharing these resources. So imagine when you go to bank, you see that their printer will not even be at the desk of the customer service, but the network the printer with all their systems. So in a central printer. So if they will just the person will just stay in his desk or her desk and initiate a printing and print the letter. So because those things they are in the same network, so that's why they are sharing resources. They're using one printer to perform their works, and other stuff. So if this person want to share file to person that in the other office, as long as they are in the same network, it can do that, share resources, share file, use do all this type of that's the same thing that happened to when you are browsing, internet is a larger network. Internet is a larger network. So when you when you are sourcing information in internet, so you see that you are connecting to that network, that internet network. So see, when you initiate a file, then your file will go and search the internet and bring down the file you are requesting for. So that is something that happened in LAN. But this one is within within an area, your office, your home, your devices. Maybe you have a router or you have a phone. Your phone, you use your phone to share data to your system. So you see that your phone and your laptop, they are in the same network, and that type of network is called a local area network. So let's look at number two. Number two is wide area network, but that is WAN. So a WAN covers a wide geographical area, often connecting multiple cities, countries, or even continents. So this is what we term as a internet. So internet is prime example of a global scale one. So it's let's just call it internet. This one is just called internet in its simplest form. Sort of you calling it wide area network, we just call it internet. You can see how it works. So you see enterprise from the diagram here, you see in enterprise is connecting to ISP. ISP is internet service providers. We are coming to that later. Then we see campus. Campus is connecting to ISP. Then ISP is connected to the internet. The same thing goes to the other city government parastatals. So they connect to ISP as well. Then the ISP is what is connecting you. That's even what happened in network communication, because when you want to access information outside your network, you are using a LAN to communicate. So when you want to access data from internet to the larger network, so you see that this is the process that the connection will go. When you initiate the connection, your network will first of all, uh, I will explain that when we are talking about MAN, but this ISP is what connects you to the internet. So let me go to MAN, then I will use that MAN to explain what I mean when you want to browse internet. So you see how the process is, it will take you to reach to the internet and get the information back. So this happened in nanoseconds, so you don't notice it. So let's look at MAN. So MAN, Metropolitan Area Network. A MAN spans a larger geographical area such as city or town. It interconnects multiple LANs and enables communication over a larger area. So you see this MAN, what it does is, let me say, in people that are staying in Lagos, they have their own uh, these service providers. They have their own MAN network there. So what it does is, when you initiate those people, if you are living in any city, every city have their own tower. Their tower that's sends information and receive information. So those when you and all based on the cities within their local areas, you see there's a local antennas. You see this MTN Max, Global Max. You see all those Max. What they does is, when you initiate a request, maybe you want to source something from Google. So when you initiate the request, what the mask does is it will take your request to your own local mask. That mask there, okay, we access your information and send it to the maybe this Nigeria now, the country, they have their base max, their basement, the MTN, the internet service providers, they have their base max. So after your local max will report to the basement max. Then that max will take that your information to the internet. Then when it surfs the internet and see the file you are requesting, it will bring it back to the base mark of the country, then the base mark will take you to your local network. Then your local mask will bring that information to your system. So that's how this works. So from LAN, when your information will leave your local area network to MAN, then your MAN will take the information to from through your ISP server and take it from that network to one, that is the wide area network, the internet, then search the information. The information will flow from that format again, from one to man, from man to LAN. So that's how the information, how this works. So let's look at network components and devices. So this diagram you are seeing here is the components that make up a network. You can see it, the web service, that is the internet. Then we see modem. You see this how it is structured. So this is how the connection is in many organizations. So the modem, this modem will take your service, your request to the internet. So when it's coming back, your internet will, when you source information on internet, the internet will send the information to the modem. Modem will send it pass through firewall. This firewall is serving as a bridge between you, the internet, and your network, your home network. So you can see it. So this firewall will filter a packet. Then before we close today, we are going to look at how to configure your local firewall. Before we close, we look at how to configure firewall. So the firewalls filter the traffic and send it if it is allowed, if something that your network allow based on the configuration, it will pass through the firewall and enter into your network. Then the router, the switch will resolve the address and send. You see the many hosts are connected to this device, this network now. So you see another router. This router is responsible for all this wireless connection here, laptop, smartphone. So this switch will resolve, and everything is connected to this switch. So this switch will resolve the address. Maybe this person, this laptop here, this desktop is requesting information in this internet. So this switch will resolve. So okay, who owns this? We are coming to that as well when we talk about the communication. We resolve this. And so this person is this desktop have this IP, then send the information to this IP without sending it to other connected devices on this network. That's why we use switch over hub. Hub is not, if it is hub, we input here. Now you see that if this person is requesting information through this internet, searching internet, when the information is coming back, you see that the hub will just broadcast the information to all the system. The person that did not initiate the information will still get information. So that's why nation are using switch instead of hub, or both of them that are doing the same function, but hub just broadcast information to all the connected devices. So that's why they are not using hub again, just there. But we are going to look at it. Okay, let's look at them one after the other. So the first component we're going to look at is network interface card. Because without this network interface, I don't think there's not your system will not have access to networking. So a network interface card, also known as network adapter or network card, is a hardware component installed in computers and devices to connect them to a network. It allows devices to transmit and receive data over the network. So you see most of your hardware component, this your CPU, they come with this interface card for networking. So this enhance the communication. And so without this network card, you see that your system you cannot network that system. So if you look at your system, although mobile phone they come with the wireless type of network card. But most of desktop they don't come with this wireless. But if you want to connect a desktop, there's what we call interface card. It's a link, a small link. If you have a an automatic wireless mouse, you see there's a link that you connect to your USB link that you put in your device in order to use that wireless mouse. So that small thing is also that is called network interface card. But that card will enable the device to connect to your network wirelessly, or if you don't want to venture into wiring, because that makes your I don't think most organizations are not using that now. Wiring this, wiring that. Is not good. Makes it not make your office very dirty. Makes your office very dirty. So they use interface that wireless one to do the connection so that it can their office will be tidy and neat. So network interface card. This is the first networking tool, because if your device do not have this interface, I don't think there's nothing you cannot connect the device to a network. It just the device will be there only for its own. So the first device we look at is network interface card. So another component we are going to look at is hub. Like I said, hub are like a central meeting point. In that diagram, you see the same thing. This switch you are seeing in this diagram is this. If you are using hub is supposed to be here as well. If it's hub that you want to use or you want to use for your connection. So this is the central point. This is where it will be, and connect all the devices with the hub. Then you see, but the security is not good. It's not good to use hub to avoid this one making requests. Everybody in the network receive the request. So hub are like
Uh,
what?
the Christian. Okay, I want to ask something.
What?
I want to ask a question.
All right, but I prefer
Okay.
if we finish.
All right. All
Um,
right.
yeah. So hubs are like a central meeting point for devices in a network. They receive data from one device and broadcast it to all other devices connected to the hub. So you see how it's very dangerous for you to use hub in communication. So let's assume that administrator want to perform a checks or request information, a secret information in a server. You see that when it after requesting for the information, you see that when the information is coming out, it's going to broadcast to all the hosts in that network. So you see, it's not good to use a hub in your networking. So, however, they do not analyze or manage the data flow, which can lead to network congestion and the decreased performance. Hubs are less commonly used in modern networks. So this is what they have been invented before switch. So this many organizations were using it before the invention of switch. So is let's look at switch. A network switch is a device that connects multiple devices within a local area network. It converts incoming data packets and forward them to the appropriate destination device based on the MAC address, optimizing network performance. So you see the difference between the hub and switch. So this switch now, if this person make a request, the address resolution protocol will just resolve the request and say, okay, who make this request, the switch will search to say who owns this MAC address. You know that MAC address is the unique address for a or every system have its own MAC address. So when the information comes to switch, if the switch not recognize know the MAC address before or have it on his catch, so the switch will ask who owns this MAC address. The address solution will look for the person that owns the MAC address. Okay, or say I'm the one that owns it. To the switch will forward the message to the person, to the IP, to the system, to the MAC address directly. So you see, it's good to use a switch instead of using a hub. So that's how switch work. So let's look at a router. A router acts as a central networking device that connects the office LAN to the internet, facilitates communication between devices within the LAN, enables network segmentation for better resource management, and provides security features to protect the network from external threats. It plays a vital role in ensuring connectivity, efficient data transmission, and network management for the office environment. So you see what router does. Con- Let me go back to the diagram. So you see the router and the router. You see uh, this router now, we send information to maybe this desktop is trying to send a message to this smartphone. So you see the message will flow from this desktop to the switch. Then the switch will look for the MAC address, which is we find it on this router. Then the switch will pass the information to this router. Then this router will send the information to the phone that owns the information. So that's how this in the router will function. And the router will also send your information directly to the internet. You see where this router is situated, located here. So it serve as a bridge. So the router will broadcast. Maybe you want to search information outside the network. The router will send the information to the modem. This modem is this modem where we find modem. Although we are going to look at it later, but where you find it is your ISP, that is the internet service providers, this MTN people, the only. So this when you send the information to this modem, the router will send information to modem. The modem we send the information to the internet. So what this modem does is to convert the information. Since your request, if you are sending a request, the modem will just translate the information to the language the internet will understand. Then when internet is sending the message back to you, the modem will convert the message back to the language your system, your device will understand. So that's the work of modem. But this modem is where the location of modem is in service providers location, so it's not located in your place. So that's the work of a router. So modem, let's look at modem. A modem is a device that translates the signals from your internet service provider into a language that your device can understand, enabling you to access the internet and do all the things you love online. So you see that is the work of modem. You know, you don't need to understand the language of the internet. What this modem does is to convert those, maybe your normal language, maybe you're typing some stuff, you know, typing some message you want to send to someone. So when the message gets to modem, the modem will translate the message to the language of the internet, the source you are seeking the information, translate it and send it to the source. Then the source, when the source trying to send the message back, is going to send it on its own language. Then the modem will translate it back to your own one, the one that you can understand and your system can understand as well. So that's what this does. To modem act as a bridge between your home or office network and the internet. It helps establish the connection and allows data to flow back and forth between your device and the vast online world. So that's the work of modem and router. So let's look at firewall. A firewall is like a gatekeeper, you know. Let's assume that you own a house. Okay, let me just use a white house. White House, or what they call it, Asorok. I want to say, let me use Asorok, the one that's near to us. So you see that when you want to enter into Asorok, you see there's a military that indicates. So before you go in, they will assess you and see and know if they can admit you inside. So that's the same thing this firewall does. And also when you are coming out, they will search you to know if you are going out with anything uh inside the arsenal. So that's what this firewall does. You just access incoming traffic and outgoing traffic. So if it's what is in the configuration, so they say that okay, this port this port number should not access anything in our network. So this firewall will say okay, when this port want to access anything, it will block it. So that's what firewall does. The firewall is like a gatekeeper or security guy for your network. It monitors the traffic going in and out of your network, follows specific rules, and blocks any potential harmful or unauthorized data from entering. So it helps keep your network and important information safe from outside threats. So you see, this is what the firewall does. So it helps you keep your data. When we are demonstrating how to configure this firewall now, because by the end of this class, I said that we're going to demonstrate. What I'm going to demonstrate is I want to filter out, although you can do it on your device, so that if you want to any link that you click that is on port 8, you see that you cannot visit the link. So I'm going to demonstrate that. So you can configure your firewall so to not any traffic that you want to, maybe you want to, someone send you a link and the link is on port 8. You see that you cannot visit that. Your brother will say that this thing is blocked, you cannot have access, or you can even block port 443, which is the HTTPS port. So you see, we're going to demonstrate how to configure that maybe when we finish this we have today. So another component on networking is wireless access points. Wireless access points are commonly used in homes, office, educational institutions, public spaces, and other environments where wireless connectivity is required. So this wireless access point is found in many of routers, even your phone, they have hotspots. That's what we call wireless access points. So they have routers, they have those things that enhance a wireless connection. So you see, most of their stuff does not come with this wireless access points. So, but you use, like I say, you use the link. There's link interface card interface to the network interface card to link it into, so that you can enhance this wireless connection. Because I don't see the need of connecting multiple cables. If you go to most of the halls in maybe these exam centers, these jam exam centers, you see that they are still using a wired connection, which might and maybe rat with just one of the cable, not that in Ethernet cable. They are, I think it's it 14 because they come with two cables. So you see, if anything happened to one of them, you see that communication will be lost on that connection. So you see, that's why it's good to use a wireless connection. So they provide convenient wireless network access, enabling users to connect their devices to the internet, access shared resources, and communicate within the network without the limitations of physical cables. So you see, you can use it to connect it without the buying extra cable, buying charger 45 and having all this network uh, clips and all this stuff. So it's that's what this helps to do in network. So another one we are going to look at, another component, and a very big one is servers. We know what is servers. So servers are powerful computers or systems that are specifically designed to provide services, resources, and functionalities to other computers or devices within a network. They play a central role in network infrastructure and are responsible for handling various tasks, storing and managing data, and facilitating communication and collaboration. So you see, servers, any system that is mapped out to provide services to other systems. So maybe in your network now, you say, okay, this system, although servers run 24 hours. So that's what these people or most organization goes on this crowd so that crowd run 24-hour services to these servers not required for you to office so that anybody that requesting any resource from that server, the server will be up running 24 hours. So you see, server is a powerful tool. It serve as is serving is just its purpose is just to serve other computers that is in that network. So the server is just a dedicated system for resource sharing. So if you want to search for any file, okay, you say, okay, let me search this system, but this system is our server. So it's just a system and issue that's serving other system. So that is server for you. Just so let's look at communication, network communication. Network communication. So network communication refers to the process of exchanging information or data between devices within a network. It involves the transmission and reception of data packets across the network infrastructure, enabling devices to communicate, share resources, and collaborate. Here as key aspect of network communication. So data transmission, that's the first aspect of network communication. Then after we finish this, then we look at the I, TCP/IP model. So data transmission. Network communication involves the transmission of data from one source device to a destination device. The data, uh, the data can be in various forms, including text, images, audio, video, or any other digital formation. So you see data transmission that when we are communicating, when you want to communicate with a computer, it's not this type of communication, although it's say the same thing we are doing now. So when you want to communicate to a system, you see that you just to share a file. So that the data you are transmitting is what we refer to data transmission. So another one is data packaging. Data is typically divided into smaller units called packets or frames. So that is the division of data. The smallest unit of data is what we call a data packet. So called a data packet or frame. Each packet contains a portion of the data along with additional information such as source and destination addresses, error detection codes, and sequencing information. Packets are transmitted independently and can take different paths across the network. So these different paths they are talking about here is the the four layers of this TCP IP model. So that's what I'm referring to. So this data, when you are communicating with your another device, so you see this your communication must pass through these layers. The the network layer and other layers in this TCP/IP model. So that's so the place that handle this data layer is I think is internet layer. So the internet layer will just handle this divide or network access layer. So it's just divide the data into a packet or frames. So that's what's happened to this place. So I've talked about data packaging. So let's go to routing and switching. So Routing and switching. Network communication involves the use of routers and switches to direct data packets across the network. Routers routers determine the optimal path. So this also it just to explain these layers of TCP IP model, because this routing and switching layer is the same thing as internet layer in TCP IP, because this place is responsible for routing. So this place is okay after the first layer introduce the package and say okay resolve the MAC address into IP. So this person will say, okay, who owns this IP? It identify it within the network and say, okay, I say this person that owns this IP. Then the routing and switching will say, okay, which part is are we going to take in order to send this message fast to this person? So that's what happened at at this point, the routing and switching. So this what happened. And so another thing we consider in network communication is bandwidth and latency. So the bandwidth in networking, in network communication is influenced by factors such as available bandwidth. So the bandwidth, what I mean by bandwidth is the amount of data that can be transmitted in a given time. So the amount of data that can transmit, you see that when you are browsing, when you are downloading some stuff that is maybe have a gigabyte file, you see that it will be slower when you are downloading it than when you are downloading a file that is a kilobyte file. You see that that one will be more faster. So that is bandwidth. Then protocol. When we talk about protocol, in network communication, there's what we call protocol. The protocol the network you use in communication, like when you are browsing your internet, you see that you are using HTTPS. When you are transferring file in the network, you are using FTP and other sort of protocol. So that's protocol. Protocol network communication relies on communication protocol, which are a set of rules and standards that define how data is formatted, transmitted and received. Protocols ensures that devices within a network can understand and interpret data correctly. For example, examples of protocol include TCP/IP, that's Transmission Control Protocol, and Internet Protocol. For internet communication, Ethernet for local area network. So that's it for protocol. I don't know, is it network that is disturbing these people that are leaving and coming? Hmm? Hello?
What did you say, please?
What?
Is I think the people that are
What did you
living
say?
now to answer for themselves.
I
Is it
don't know
network that is
what is
making
happening.
people live on? Well, with you, sir. Maybe network is disturbing them. Yeah, we don't know.
Maybe you can go on with your question. Can you
I've
hear me?
gotten clarification. I've gotten clarification.
So what do you want to
I
ask
wanted to
before?
ask. I wanted to ask a question about the diagram where the
Oh,
switch is. You were talking about the hub. I was like, that is exactly where the switch the hub would have been.
yeah,
Where
yeah,
the
that's
switch
the yeah,
is in
yeah.
the diagram.
That diagram.
Yes,
If
I've
if
gotten
there
that.
if you want to use a hub, that's where the hub supposed to be in that diagram.
Though the diagram looks complex.
What?
Though the diagram looks complex.
It's not so. It's simple. Nah? Let me go back to it. This is it, right?
Yeah.
So, what is complex about the diagram? Let me explain.
When you go to router then sends it to wireless network. Like
No,
what
this
I don't, I'm not saying it's hard to understand. Just saying it's big, bigger than all those I've seen.
okay. Well, so what this router do, for network segmentation, the router help in network segmentation. So you see that this router now is connecting only this wireless network that is there. You see the wireless now, the laptop up, the one that is up, and the one that is the smartphone. So this part of the segmenting the network. So it's used the routers are also used for segmenting of this network. Then connect it to this switch. Then this switch will connect the route. This second router that's connected to a firewall is what is giving internet to all these devices. So that is it. It enhances in segmentation. So that is the work of this router. So let's look at how to configure a firewall because so if you are you joining the class, anyone that's joining with the system so that you can do let's do it together. Huh? Who is joining with his or her phone?
I'm joining with my phone. Why did you ask?
No, not phone. I mean your laptop. I'm trying to show how to configure the firewall to filter out a particular port or any type of traffic you want to filter out. Olmida, are you there? Hello, Aishat.
I'm here. I didn't join with my system.
That means you guys will be looking at me now, doing it. But do you know how to do the configuration?
No, I don't.
All right. So the first thing
See the
you are
packet
going to
data.
no, not packet data. Your system firewall.
Okay. I have a
Yeah.
system here that I mean, if it's something I can follow you, I will follow you. But I'm
Okay.
closing my
So
system.
what you're going to do is go to the menu bar, then you just search for Windows security. You type Windows security, the stuff will pop out.
Windows security.
Yeah, when you type on your search bar, you type Windows security. Although let me, I don't know, let me share my screen and see so that you can see the.
Okay, Windows.
Yes,
You
I
should
wanted
click
to
on
say
it,
you should
right?
share your screen and practice.
Open it.
Yeah, you can see my screen. This is my Windows security here. You can see it. This is the home. You can see it, ba?
Ah, it's still
Yes.
Yes.
opening.
Olumide, we are just coming back from. I don't know where you went. So this is the
Ah,
Windows security. You
that's
can
open.
see you can see that virus and threat protection is on.
Protection.
Account protection. You see all the stuff that is on here. Then you see firewall and network protection. So this is where we are going to go now. The firewall, and we just click on firewall and traffic. But before then, let me browse. I don't know if I can share that screen so that I can browse my router, the router that I'm using now. Let me browse on it and show you. You see that I can visit the router now. So let me just browse. Then when I configure the rule now, you see that I cannot have access. So this is the router that I'm using, hyperlink. So you see that I can browse it. You see that it's not secure. It's using port 80 for its communication. The router is not secure as you can see
That
here.
port 80 means open. port.
What?
Port 80 is an open port.
So you see the router stuff here. This is the router, and port 8 is always open. Even port 443 is always open as long as it's internet. So you can have access to that. So this is the router. You see that I have access to it now. So let me go and do the configuration now. So you see that after the configuration, you see the message I will get. So let's go to firewall and network. So this is where you can configure your firewall. When you click on it, it will open. So this is firewall. If you want to do a configuration now, so where we are going to, when you open here, are you doing the same thing with me?
Yes, sir.
So when you come to this page now, you go to advanced settings. You go to advanced settings. Click on it. It will ask you for
Yes.
yeah.
You want to allow the app to make
Yes,
it.
you say yes.
Yes, yes.
So I think it's going to open another page.
It's still loading.
Can you see the page it opens?
Mine did not open any page.
Hmm?
It has not
Let me
opened any
ignore.
page yet.
Yeah, that's open.
It
let me
has
just
opened.
share that page. Yeah, let me share that page.
Window Defender Firewall with advanced security.
Okay. Yes, that's the page it open. So you can see the page right number.
Yeah.
Can you guys see it?
Yes.
Yes, you can see it.
Okay. So if you want to filter a particular stuff, so here you see at the left hand side, you can see the inboard rules. If you want to do inboard, that's the information that's coming inside your. If you want to take any rule that's coming inside your device, you can go to inboard. If you want to go configure any rule that's going outside your that go from your system and go outside, that's the browsing. When you are browsing, you are accessing data outside. So when data is coming back to you, so this one is inboard. So let's go to outboard rule. So when you click on outboard rules, you see the rule that has already set, and this one is working. So but if you want to add a new rule, let me just add a new rule. So if you want to add a new
There is
rule,
no rule.
the do you click on outboard rules?
Okay, yeah, I have. There are.
Yeah, click on outboard rules. So let me so if you want to add any rule, you go to at the right hand side, you will see new rule. You click on it. Just wait for it to load. Don't know why. So can you see
Well,
can you see this new
yes,
window? Can you guys
mine has
see it?
loaded. Yeah.
Okay, you cannot let me share that window as well. Just when we click on new rule. So let me share the new rule we are configuring now.
Which type of rule would you like to create? Program
Um,
port,
which one?
predicament, testing.
Wait, so but can you guys see the dialog box that pop out? I don't know for any reason I can't share that screen for no reason. I don't know why. But anyway,
Mine should.
yeah, it is showing here. What I'm trying to do is to um, uh, walk us through on how to set the rule. But it's not showing here. It's just showing that window defenders.
On clicking that set rule, it will bring out some
Can you see
radio
it now?
buttons. Yeah.
Can you see it now?
Yes, we can. Olamide, respond now.
Yes, yes, yes.
Okay, so this new, you see that new outboard rule wizard. So here is what where we configure the, if you want to set rule for programs, the program that you don't want to enter into your your device, you can choose a program. But this practice we are just using a port. I'm just trying to set a rule for port, a port that I don't want my system to access. So you just click on port because it's port that we want to set. So we go to next. After you click port, you go to next. So the port we are trying to filter is TCP port. TCP, we are using the protocol with TCP, not UDP. This you know the difference between the two of them. TCP is when we want to it's it kind of secures communication, although it delays some. There's a delay, but UDP, if you want a faster communication, you can use UDP. UDP just stands for User Datagram Protocol. So, but TCP is Transmission Control Protocol. So, but UDP, where they use it is in this our call now. The type of protocol we are using in this call is UDP because it helps in video call, and that's what they use in video call. But you cannot use TCP in video calling or this chat, video chat. You cannot use a TCP. We use UDP. So in this call the protocol we are using in this corner is UDP. So I want to filter a port. So the ports I want to filter, you see the example, you input the port here. So let me put port 80. I don't want my device to access anything that's coming from port 80. So I put port 80 here, then click next. So here it asks
So
you
how
to
did you get
the
here?
okay. Are you in this form? Are you here?
Where I am now is that first place after clicking the rule, new rule.
Okay, this place.
Yes.
So you click on port because I told you I just explained this stuff. So we want to set if you want to set a program, the program that you don't want your system to access out there. Maybe you see a program out there that's malicious, then you can come here and set the rule, click on program, then go to next and set the but for this demonstration, I just want us to filter for a port. So we click on port. So I click on port and click next. Are you there?
Yeah.
So you click on, then when you come to this page now, you put we are you choose TCP, then come to this place, put 80. So we don't want you, if you are configuring this rule now, we don't want your device to visit anything that's coming from port 80, that's hosted on port 80. That is the website. Any website that's hosted on port 80, you don't want your device to access that
To
port,
visit.
and you know that it's a malicious. Anything that's hosted in port 80 is not a secure something. So you can configure that rule as well. So when you put 80 here, you click next. Are you there?
Yeah.
So this another port here is the action. What they want this thing firewall to do. So you can choose allow the connection. This includes connection. So it explains this. So this includes connection that are protected with IPsec or other stuff. So but I want to block this thing entirely. I don't want anything. So you see you can choose block, just block the stuff entirely. I don't want my system to access anything that is hosted on port 8. So we choose block. Are you there?
Then next. Yeah.
Yeah, you click next. So yeah, what does this rule apply? So when does this rule apply? So the domain, private or public. So we tick all the boxes. It applies to any domain that is hosted on port 80. I cannot access it, even if it's private or public. So you see,
And
when
what's
the
then?
public say that apply when a computer is connected to a public network. So even if your computer is connected to public net, that is the Wi-Fi outside the network. Maybe you connect to a Wi-Fi, uh, public Wi-Fi. So this rule will apply also to public if your device is connected to public. Then private, even if you are using your own network to access. So that's what this page means. So after that, we click next. So you are going to name the rule. So any name that you want to name the rule that you can just configure, you can just write it filter port 80. You can just name it anything you like. Then description is optional. And maybe you want to say a description for this. Want to name a description. But if you don't want to uh, name anything, it's just optional. You can just leave it like that. Then after that, you click finish. I'll just leave it like that. So that is all for. So you see that we have set that rule. Let's go back to this. So you see that the rule is now configured. Can you see the rule here? Can you see where I'm pointing now? You can see it here, up here as well. Hello.
Yeah, with you, sir.
So let me try to access that this my router now that's hosted at port 80. You see the information. So let me just refresh this thing now. So normally if I
What?
refresh it, this
Why is it not ticked good as others are ticked good?
what do you mean? You see that
Out.
is bad now. This one is this rule is not set now. This rule is allowed. That's why they are ticking good. But this one is blocked. You see the block button here?
Okay, okay, okay.
Yeah, it shows that you are blocking any traffic from port 80. So let me revisit this my router now. You see what will happen. And you see that I cannot access you see your internet access is blocked. You see you cannot access anything that's hosted on port 80. If there's any website now that's on port 80, you see that I can never access it. I cannot access the network. Anything
How did
that's
you get to this place?
eh?
Yeah, what did you search for that showed this?
I trying to that before we started this configuration, I used my I tried to access my router homepage, my router this thing to browse my router. Then just my IP. You see, it is blocking any request from port 80 because this thing is hosted on port 80. This router is hosted on port 80, so I cannot access the router here again because of I've configured the rule to block any request sending from my system to port 80, anything hosted on port 80. So you see, that's why this thing blocked it. So if you can leave your own like that, you can leave your configuration like that so that if you mistakenly click any link that's hosted on port 80, this rule will block it.
Okay.
Yeah. But I can just let me I can just disable the rule. Let me disable the rule. I can disable it here. When I disable it now, so let me try to visit the stuff again. Let me refresh it. You see that I can visit it now. Do you see what the work of firewall now? I have disabled it. If I enable it again now, let me enable it. You see that I will not have access to it again. Let me go back. You see, you see the worker. Check firewall antivirus configuration running system. You see, this has been blocked. But that is the work of firewall. to block traffic. Let me just disable it. So that is the work of a firewall. So you can still set some rules that you want. You can just use your hand and configure some rules that you want on your system. If you want to configure it, the same process. If you want to configure inbound rule, the same process. If you want in outbound, the same thing. So, but know that outbound is the site you are using your system or anything you are using your system to visit. So, that's outbound. And then inbound is the one that is coming to your system from the internet. So, you can configure the rule based on your preference, what you want. But that's how to access a firewall. But most organization the this like this diagram now, this firewall you are seeing here is not this one that you will access. There's third party firewall, you know, there's there's organization that provide firewall software for organization. So the firewall is like all these networking tools we are seeing here, devices. It comes like switch also. So the firewall you can organization they have their own processes of configuration. So organization can configure the firewall based on their preference, but based on what they want. So and the same thing that's happened there. It's not this type of firewall that's in your system that organizations are using that organizations that are fighting uh, security security of their organization. It's not this firewall here they are using, although they also set through in their individual system, but the firewall they have firewall and like as a device, so the firewall will just filter the traffic as well for them. It comes like a software, like all this app we are using, firewall comes in that form as well. So that is it. I don't know what is happening today. Why everyone is leaving? Hmm? Bless, are you there?
Yes, I
Olumide,
am.
I don't know. This is let's say that this is annoying. Someone will just come in and just left. I don't know. It's so annoying, you know. I don't know why. Assuming that
No, we are here.
I just started this, I just leave, but you know, it's so annoying. Anyway, let's continue from here tomorrow. I don't know why. Even I don't know. Let's continue from here tomorrow.